Okay, so this is Mr. Ashton going through the practice test I've set as half-term homework. Okay, so the first question. The points A, B and C have the following coordinates. A line through A is perpendicular, so I'm going to underline that word because I know something about perpendicular lines with the line BC. It intersects BC at the point D. Show that the equation of BC is x minus 4y plus 11 equals 0. Okay, so to start off with, for 1a, what I'm going to do is I am going to work out the gradient of BC, and then I'm going to put it through my formula that I know from the 6 facts I learned from y minus y1 equals m x minus x1. Okay, so m is the gradient of BC, so let's work out the gradient of BC. So grad BC is equal to the difference in y's divided by the difference in x's. Okay, so the difference in y's between B and C. So I don't like that minus there. I need to be wary of that. I'm going to do B's coordinates take away C's, I think. So 1 minus 4, that's going to give me a negative, but I have got that negative there. It doesn't really matter, but I just need to be careful. So 1 minus 4. Now because I did 1 minus 4, that means I have to do minus 7 first this time. Minus 7 minus 5. So that's going to give me minus 3 over 12. Oh, over minus 12, sorry. And then the two minuses will become positive. 3 over 12 is the same as a quarter. Okay, so there's that first bit done. But now I need to go and work out the equation of the line. So that would be y. Now I can either chuck in B's coordinates or C's coordinates here. And as C has no negatives, I'm going to go with that. So y minus 5 equals a quarter. And then x minus 4. Okay, now what I'd be tempted to do here is bring the 4 over to the side to get 4y. And then minus 20, and that equals x minus 4. Now at this point here, I'm starting to think I've made a mistake because I'm told that the equation was going to be plus 11. I can quite clearly see from my working that minus 20 and then minus 4 isn't going to make positive 11. So that's what I'm worried about here. So I think I've spotted what I've done. Just see if I can find a pencil. I think if I go back to my equation here, where I've chucked in minus 5, minus 4, I think that should be that they're the other way round. I think I've chucked in x coordinates. Let's have a look. Yeah, that's exactly what I've done. So this should have been 5 was the x coordinate, 4 was the y coordinate. This should have been minus 4. This should have been minus 5, okay, which is why it's really, really good that they give us what the answer is, because it told me to go back and check. So let's try that again. I'm going to have 4y, have minus 16 this time, because I'm timesing that minus 4 by 4, and then I'm going to just get x minus 5. Now they've got it in the form that the x is positive and the y is negative, so I'm going to bring everything from this side over. So I'm going to get x minus 4y, and then minus 5 plus 16 is positive 11, which is exactly what they wanted. Okay, so there's part A done. Oh, not quite. I've got to find the equation of AD. Now this is when that condition of A and BC are perpendicular. Now that tells me that their gradients must times together to make minus 1. Now I already know that the gradient of BC is a quarter, so times by what must equal minus 1? Well, it's always this one flipped to its reciprocal, and one of them must be negative. As that's not negative, this one must be negative. Therefore, my gradient of AD must be equal to minus 4. I can say as a quarter times minus 4 equals minus 1. Okay, that's the condition from perpendiculars. And then from there to work out the equation of BD now of AD. Sorry, I'm not told the I'm not actually told the coordinates of D, so that means I must only chuck in A. They're the only ones I can chuck in. So then from there, I'm going to say AD, and that is going to give me y minus, now A's y coordinate is minus 1, so it's minus 1, which is eventually going to be a positive 1. And then I'm going to get minus 4 x minus 2. So that's going to give me y plus 1, because minus 4x, and then positive 8, minus 4 times minus 2. Chuck everything onto one side, try and keep the x coordinate positive, so this time I'm going to pull everything onto this side. I'm going to get 4x plus y, and then I'm going to have minus 7 equals 0. Okay. Part B says show that the coordinates of D are 1, 3. So to go and do that, I know it's where the lines BC and AD intersect. So that basically means I'm just solving simultaneous equations. So I've got two equations already. I've got x minus 4y plus 11 equals 0. And my second equation, which I just worked out, is 4x plus y minus 7 equals 0. Now, it doesn't matter how you go and solve these. Any way using simultaneous equations is fine as long as it's correct. I'm going to use the substitution method, so I'm going to change 2 into y equals 7 minus 4x. Just taking the minus 7 and the 4x over, and then sub into 1. So I've got x minus 4, and the y has just changed to 7 minus 4x, and then plus 11 equals 0. So I'm going to get x minus 28 plus 16x plus 11 is equal to 0. So I'm then going to get x plus 16x is 17x, minus 28 plus 11 is minus 17. So then x must be equal to 17 over 17, so x equals 1. Okay. And then from there, because I know what x is, I can now find what y is by subbing it into this bit here. So therefore y equals 7 minus 4 lots of 1, so y equals 3. So my coordinates are exactly what they said they need to be, they're 1, 3. So that tells me that my 7 marks that I've already previously done must be correct. That's the nice thing about being told, show that. Okay, so for part C, I'm asked to find the length of CD. So to find the length of CD, what I'm going to do is find C's coordinates, which I'm given, 5, 4. D's coordinates I've just worked out, but if I'd messed up the previous thing, I could just use what they told me in the question. Now, what you might want to do is you might actually want to go and plot it. So we've got 1, 3, and then I'm going across to 5 and up to 4, so then 5, 4. So I've got that thing there, but basically what that's done is it's just created a right angle triangle. Now I like to think of it as just using a bit of Pythag here. If that's 1 and that's 5, I've gone across 4. And if that's 3 and that's 4, I've gone up 1. So then it's just going to be a case of saying that it's 4 squared plus 1 squared square rooted because of it being Pythagoras. So that's going to give me root 16 plus 1, so root 17. I could chuck it into the formula that we learnt as well, which is difference in x squared, add the difference in y squared, and then square root all of that, but it would give me exactly the same answer. Okay, little bit of a sort of weird answer there, root 17. Part of me is thinking, is it right, is it not right? Well, at the moment there's only one way I can find out, which is looking at the mark scheme, which I don't have. Okay, and you're in the same position. Okay, so what I'd do is I'd stress just going back to look at it, does it make sense? I'm doing that subconsciously in my head. I'm looking at 5 and 1, I know that's a difference of 4, I know that's a difference of 1. I'm checking 4 squared is definitely 16, 1 squared is definitely 1, 16 add 1 is that, and I know the coordinates are correct. I've taken them out straight out of the marks, out of the test. Okay, so for part D, the final bit here, the line AD is extended to E so that D is the midpoint of AE. Find the coordinates of E. Okay, that's not as bad as it sounds. So if I think of AD, I know that A's coordinates were 2 minus 1. And then if I try to do this roughly so it's correct, 1, 3. So 1, 3 would be what, coming back to here and then up to here. So that would be D there, would be 1, 3. And we're told that D is the midpoint of AE. So if I look at my drawing, if I drew AE, whatever that distance is there, it should be the same distance here to E. So I'm not even going to use a huge amount of like A-level type maths things to work this out. and say that I've gone back 1, so that means I must have gone back 1 here for it to be the midpoint, so that's going to have to be 0. And then from here I've gone minus 1, and I've gone up to 3, so I've gone up 4 places, so that must have gone up 4 as well, so I'm assuming it's going to be 0, 7. Okay? The way that I could do it properly mathematically is that we know that the midpoint formula is x1 plus x2 over 2, and then this would be y1 plus y2 over 2. Okay? So I actually know in this case that x1, so we say that we don't know what e's called, so I'll call that x1 plus 2 divided by 2 is equal to 1. So then it's just solving an equation. So I'd have it as x1 plus 2 is equal to 2, bring that over as times by. So then x1 is equal to 2 minus 2, x1 is equal to 0. And the same with the y's, y1 plus minus 1 all over 2 is equal to 3. So if I bring that round, I get y1 minus 1 is equal to 6. So then y1 is equal to 7. Okay? So let's have a look at surds now. So I've got 10 root 3 minus 1, and you have 4 minus root 3. Okay, so what this is called rationalizing the denominator. So we don't like to have any surds on the top and the bottom. So what we do is this one here, just times top and bottom by the same thing, and you just change the side here. So the sign here, sorry, so minus becomes a plus. Whatever I do to the bottom, I must do to the top. Because there's 2 parts up on the top, I'm just putting that in brackets and extend that divide by sign. Okay, so the first one is going to give me 4 times 10 root 3 is going to give me 40 root 3, and then that 10 root 3 times positive root 3, there's a couple of ways of writing it. I'm going to write it as 10 root 9, which eventually I'm going to work out, but you could have said the root 3's times each other to be just 3, and then 10 times 3 is 30. I mean, I'm going to get the same thing here by doing root of 9 is 3, then 3 times 10 is 30. And then minus 1 times 4 is minus 4, and then minus 1 times root 3 is minus root 3. And then on the bottom here I'm going to get 4 times 4, which is 16. I'm going to get 4 times positive root 3, which is plus 4 root 3. On the other side I'm going to get minus 4 root 3, and then I'm going to get minus root 9. But again, some people call that 3, it's fine. Now here, these things will cancel. Plus and a minus are the same thing, cancel. That's why we do this step here. Okay, so now it's a case of me just sorting out all of the jumbledness up of that. So I'm going to have 40 root 3. I'm going to take away root 3. That's going to give me 39 root 3. That 10 root 9 is going to be 30, but 30 take away 4 is 26. So I'm going to have plus 26. And on the bottom here, I've got root 9, minus root 9, which is minus 3. So I'm going to have 16 minus 3, which is 13. That makes perfect sense now to me. I know I'm feeling pretty confident that I've got that correct, because 13 goes into 39 and it goes into 26. So I get 3 root 3 plus 2. Okay? And then for part B, so that's part A. For part B, I'm going to get something not too dissimilar to what I've just done. And it's easier actually, and it's worth the same amount of marks. I'm going to get 2 times 5, which is 10. So 2 times the 5, and there's 2 times minus 20, which would be minus 2 root 20, but there's a square number that goes into 20, which I'm going to have to deal with in a second. And then here, I'm going to have plus 5 times root 5, so I'm going to have plus 5 root 5. And I'm going to have plus times a minus, it's going to be a minus. Then root 5 times root 20 would be root 100. Square number that goes into 20 is 4 times 5, plus 5 root 5. And then this actually can cancel down to be a minus 10. So 10 minus 10 is gone. And then I'm going to have minus 2. Now, the square root of 4 is 2, and this 2 here multiplies that. So the root of 4 being 2, 2 times 2 is going to be minus 4, and then root 5. And I'm going to have plus 5 root 5. Then minus 4 plus 5 is just positive 1, or just root 5. Okay? Okay, so for part 3, or question 3, we're told that a curve has an equation, so we're doing tangents and normals here. So we're told that y equals x squared minus 9x and then plus 13. We're told that point P has coordinates 6, minus 5 and lies on C. Find the equation of the tangent at P. Okay, so that's nothing too bad here. What I need to do is differentiate, and that will give me the gradient of the tangent at any point. So I get 2x minus 9. I know that P has the coordinates 6, minus 5, and I want to find the tangent at that point there. So at this point, x equals 6, y equals minus 5. So at P, 6 minus 5, dy by dx is equal to 2 lots of 6 minus 9, which is 12 minus 9, which is 3. Okay, I might say dy by dx there. Now that is the gradient of the tangent. If I wanted to work out the gradient of the normal, then I'd have to have those, the normal being at right angles to the tangent at the same point. Its gradient would be minus 1/3, but I'm not a master of the tangent. It's said in bold to find the equation of the tangent. So I now use the same formula that I used question 1. Y minus y1, so in my case y minus minus 5, careful with the minuses, equals 3, x minus 6, so I'm going to have y plus 5 is equal to 3x minus 18. And then differently to question 1, if we've got it in the form y with no coefficient, we tend to just say it's a line of y equals, but if it had a coefficient, say it had 2y or 3y or whatever, then what I'd do is I get everything on one side again. So I'd say it's 3x, and then it's be minus 23. For part B, slightly different, looks a bit harder actually. It says the point Q lies on C such that the gradient of the normal is a 7th. Find the x coordinate of Q. Okay, that's quite a tricky question. Okay, so what I need to do is I need to know that the gradient of normal is equal to 1 over 7.
Come on.
Morning, how are you doing this? It's alright, yeah. Therefore, the gradient of the tangent must be minus 7. Okay, so that tells me that dy by dx must have been minus 7. Therefore, 2x minus 9 is equal to minus 7. So 2x would have been equal to 2. So x would have been equal to 1 in that situation.